Hello and welcome to another tutorial. So this time around we are going to be building on the security camera and security console setup that we put together previously. So what we had before was we had cameras that could rotate and we had a central console that was linked to multiple cameras and we could switch between seeing the actual camera feeds there. So what I want to get set up this time is having those cameras be able to react to things in the world. So having them detect the player and that changing their behavior. So providing some visual indications and some behavioral changes there. So that way then we have these security cameras that could also then be reacting things to stuff in the environment there. So let's dive on in. So this is the setup we've already got. As I said, we're building on that security camera project. So we've got our different cameras, and what we need to then do is we want to have some FU indicators, because if this is something where the player is kind of having to interact with them from a strategic point of view, we want it to change the player's behavior, we need to have feedback of, okay, what is the angle that these cameras can see, what is the sort of range, and also is the camera actually reacting to us. So there's a few things that we need to set up with that. So what I'm going to do is start to set up a couple of those key things for the security camera. So stuff that I know we're going to be needing. So a few things that we're definitely going to be needing. We're going to need our detection angle. So this is going to be the angular range in which we pick up that something is there, and this will be the half of that angle. So we'll call that detection half angle, which I will set initially to probably something fairly large, like I think let's go with 30 degrees. So that'll mean the effective angle is actually 60, but it's 30 degrees of either side of where we're facing. So that looks good. Alongside that, we're also going to need a detection range. So detection range. Let's also make that, let's go for 20 meters to start with. So that's how far away we can detect something. So, okay, we've got our half angle, we've got the range. We want to be able to efficiently be knowing whether we can see something or not. And the way we're going to have to know for certain that we can see something is we would have to do a raycast or some form of cast there. But that's something where it gets expensive if we're continually doing that, especially in a cone. We don't want to be doing that. So we need a way of being able to filter and identify that we have things as a potential sort of target, as something that we need to consider. So what I'm going to also have is a collider. And I'm actually going to use a sphere collider for this. And there's a couple of reasons for this. So there's different ways of doing this, and in the vision and sensor project I went for a different approach. The vision and sensor one, I went for things register. This one I want to intentionally show a different approach. In this case, what I will do is I will have a collider that keeps track of things entering and exiting it that match particular criteria. And then I'm using a sphere collider because that way then I don't need to move the collider, which means I'm not doing any updates for that. So if it was a collider that was actually on the object and it moved with it, that would then mean it's continually getting invalidated and has to be rebuilt. So this way it avoids having that happen. It's going to just always be static. And a sphere collider is going to be generally something that's going to be a lot quicker to test against. So that's going to be our detection trigger. We also are going to have a light. So detection light, because that we want to be able to change the color of it. So what I'm going to explicitly have is color, and then color, nothing detected. which will make that a green. Then I want to have a color fully detected. That can be a red. So that looks good. So when it sees something, I don't want it to just go immediately, it's fully detected. I want there to be a bit of a build up. So what I will do is when something is there, I will have a number that ticks up. And that number as it ticks up is going to indicate how detected something is. And then when something's out of the camera view, that can tick down. So I will also have a float detection build rate. So the higher this is, the faster something will become detected. So I'm going to, if I started at say 1, that would mean it would take 1 second for something to be fully detected. If I started at like 0.5, then that's going to mean it would take 2 seconds to be fully detected. I'm going to then have a detection decay rate, which I'll set as the same for now. So we'll just group these neatly. General. So that looks good. We've got a pretty good range of all of the ones we'll need there. So with that set up, we can configure the extra little bits that we need on the particular cameras. So I'll do this directly on the prefab. I'll get that stuff updated. So what I want to do is on the actual camera, so on the section that moves, that's where I'm going to attach the spotlight. So I'll put in a spotlight. What I might actually be able to do, I'm going to anchor it to the actual camera is going to, I would say, be pretty right. So that looks good. I will bring it a little bit forward. Probably about 0.3. Just because I don't want it behind any of the meshes, things like that. I'm going to leave it not casting shadows. I might up the intensity a tiny bit. So that's good. We've got our light set up and I can link that up. So the collider, the pivot is one of the things that changes. So I don't want the collider to be sitting on the pivot. I want it to be sitting on this parent object. So I'm going to remove the mesh collider and I'm going to add a sphere collider, but I will relocate where, I'll relocate where that sphere collider is. Can actually, these don't need to be. It's generally good. You want those always defaulting at 0. It's not really going to matter. I've already got the things manually placed, but just nice to have them positioned appropriately. So that gives us a good sense for this. So we want to position this roughly about where the pivot is, which is going to be about minus 0.3, and probably if we lower it, so not that one, probably about minus 0.2. That looks pretty good. The radius of it will just default as 1. We're going to be changing that anyway. That then means we can link that up here. So we've got our detection trigger, and we need to make sure we set that to being a trigger. So that's good. The other thing we want to do is, because we only want to react to particular tags, so I'm going to have a list of string detectable tags, and we'll just populate the player in there to begin with so that we'll be able to pick up the player. So that's good. That means all of our cameras now have that set up on them, linking to the particular lights. So we can start to then get a couple of key things set up. So that's the collider and lights. So the linked camera, that one we don't need to make any changes to. It's the detection light. Its color, it's going to default to nothing detected. Its range, detection range, and its angle. So the spot angle is that half angle times by 2. We then want to also update the trigger radius, and that's going to be our detection range. So that means we're properly synchronizing those to begin with. So that's good. So then what we can do is, and I'll actually put this in here. I'll have our void on trigger enter, and we'll have a void on trigger exit. First thing I'm going to do is check that the tag matches. So if detectable tags contains that, and we'll make that a not. Just means we reject those early on. We don't need to check things like range in that. So these are going to be things that are potential detectable targets. They're not going to be things that are guaranteed that they are currently detectable. So we're going to need to store a bit of information about them. So what I'm going to do is I'm going to have a class potential target, and it's going to have a game object, keep track of if it's in the field of view, and the detection level. So when we go and something enters here, I'm going to need to have something where I'm tracking those. So the easiest way for this is where I generally use something like a dictionary. Potential target, candidate, or actually we'll call it all targets. So this is stuff where dictionaries can make a lot of this significantly easier. Because what I would do then is all targets, other game object is equal to a new potential target. We populate everything. So the linked game object is other.game object. These other ones, their default values will be completely fine. Then when we exit, we can do all targets, remove. So we are removing it from that list of things. So skip if the tag isn't supported. To our target list. Remove from the target list. So now we've got potential targets. Now these are not necessarily all of the things that can be seen. These are just the things that we might be able to see. So this is stuff where what we're going to then need to do is update these. So I'm going to put these up here. And then in our update, and I'm going to do this before I do anything else because this might change the behavior of the camera. So update camera, update, update target info. Maybe refresh is a better term for it. So the point of this refresh function is it's going to go through and check if these targets are visible If they are, then that's going to result in their detection going up. If they're not, it's going to result in the detection going down. It won't ever result in them being removed from the list. The only thing that can cause them to remove from the list is moving out of the trigger zone. So we're dividing up the responsibility there. So first thing we need to do is we need to loop through all of the ones there. So target is going to be a key value pair. So what we would actually have here is our target info is target.value. So first we want to check if it's in the field of view. Is the target in the field of view? So what we do to calculate that is firstly we get a vector to the target. So that will be our target info, our linked game object, transform dot position minus, and I'm actually going to go from the, there's a few things we could use for this. I think in this case what I will do is I will go from the camera's transform position feels the most correct. Or we could just use our transform position. They're going to be very close, so it's not going to make a huge difference. So that's good. So the way to then check if it's in the field of view, we have our angle. So this is where dot product comes in handy. Because dot product, if you take one vector and you calculate the dot product of that vector, normalized, with another vector, also normalized, that result, that single number you get, is the cosine of the angle between them. Now what's great about that is if those two vectors were the same, the value would be 1. So if the object is directly in front of where we're looking, we would get back 1. And as it sweeps to our left and right, the value decreases till when it is 90 degrees on our right, so directly on our right or directly on our left, then it's going to be at 0 and then it goes to negative. So that makes it a really easy and quick thing to compare. So that's why you'll often see in vision systems dot product and a comparison like that happening. It makes it a lot quicker and a lot easier. So because we don't want to be doing cosine of the angle every single time, I'm going to have here cos detection half angle, and then I will down here case the detection data. Cos detection half angle is mathf cos. Now we need to make sure we convert this to degrees, sorry, from degrees to radians, because cos uses radians. So that's good. So whatever that is, if the dot product of the vector to the target with the vector where the camera is looking, if that value is greater than or equal to cos detection half angle, then we know it's within our cone. We know it's potentially visible. So f vector 3 dot dot and linked camera transform forward with vector to target normalized. If that is greater than or equal to cosine of this, then we know it might be visible. Otherwise, we know it's definitely not visible. Ball is visible. So we'll default that to false, because then what we do down here is, okay, well, target info in field of view is equal to is visible, and then f is visible. Well, target info detection level, we're going to do a clamp to keep it between 0 and 1 of target info detection level plus detection build rate times by time dot delta time. And then the flip side of that is if it is not visible, we use detection decay rate. Update the detection level. So, okay, we know that it's potentially visible at this point. So this is where what we would do to confirm it is we would do typically a raycast. So we could do a physics raycast, and we want to think about the different, because there's so many of the different physics ones we can be doing. We want to get out our hit result. We do want to be indicating a distance. So that's stuff that we know we need. So we're looking at something like this. But we also want to be able to have layers in there as well. It's good to be able to have the layer mask. So I'm going to say the position is going to be linked camera transform position. It's going to be linked camera transform forward is the direction for it. Then we need to flip through. We provide the hit info. So out hit info, detection range, detection layer mask, and query trigger interaction. We don't want it to interact with triggers. So raycast hit info. So that means we need this detection layer mask that we'll set up. That will also allow us to, because we want to make sure the camera doesn't impact on itself. So that's easy enough to do. Because what we're going to do then is we'll come back here and we'll put the cameras into their own layer. That's just going to make it really easy for us having them not actually get impacted by this. Which we already conveniently, the cameras, we already have a security camera layer. So I'm just going to change everything to that. So that's good. Everything's in that layer, so it means this will not get impacted on. The colliders are all turned off anyway, but it just ensures that it's just not completely ignored. We can turn off, so we don't want it to impact on essentially anything other than default or water. It's not going to look at, which is good. So, okay. That will be able to confirm that it's successfully doing the raycast. So then what we need to make sure is that what it has hit is this object. So this is something where potentially you might need to traverse through parents. So it's something where you want to keep in mind the collider sort of set up on your object. Now in our case, the player, the collider is on the actual parent objects, that's fine. But if you had really complex compound objects, that's something where you might want to look at sort of setting up maybe a custom collider used by the security cameras, something like of that. So what I'm going to do is check if hitinfo.game collider game object is equal to the target info.linked game object, and if it is, then is visible is true. Check if we can see the target. Now we could do something like a sphere cast, things like of that, if we wanted to have a bit more of a range. That is obviously going to be a bit more expensive, but a potential option that you could be doing there. You could also raycast to different locations on the game object. Those are also options you've got there as well. So that's pretty good. What I want to also then keep track of is, well, what's our current overall target? So I'm going to keep track here of float highest detection level, which I'm going to set to 0. I will also have game object currently detected target, which this I'm just always going to reset to null, because then what I will be doing here is a couple of things that can be simplified. Is if target info detection level is greater than the highest one, then we update the highest detection level, and currently detected target is equal to target info linked game object. Found a detected target or new best, new more detected target, because that, what we can do here is F currently detected target. This is going to allow us to update the color of the light. So if it is not equal to null, then detection light.color is a color lerp from no detection color to color fully detected, and it will be based upon the highest detection level. So that works. Otherwise, we can just reset the light color. So otherwise, detection light.color is color nothing detected. So that looks pretty good. I will move this up. And I will actually make this something that is public or publicly gettable, but only privately settable. So that could be a useful thing to be able to retrieve. So that looks pretty good. I won't mess with the rotation, stuff like that yet. That is a thing I do want to mess with at some point, but not just yet. What I want to do first is I should expect to be able to see these cameras. So we can see we've got, this one's showing green. So what I want to hopefully do is walk into here and see a color change. So I'm not currently seeing a color change. Now that angle is pretty narrow. So we want to make sure that it has actually updated the angle on the spotlight there. So it does say that it is a 60-degree angle. Does look about right. We should be getting detected at this point. So that's something where what we can do is we want to check, do we actually have any targets? Because we might not. So there's potentially things that could be messing up there. So we can see we do have targets, and we do have the player, which is good. So we've got the vector to the target is being calculated. The dot product test passes, so that's good. And it has hit something, which is great. So we can then see what has it actually gone and hit. So in this case, this one's hit the floor. So that's all right. We can run again, see what this one has hit. So again, the floor. And if I put a breakpoint here, we'll know when it's looped around. So it's only one of the cameras is actually seeing anything, and it's only picking up the floor. So that's something where that particular camera, we'll check which one it is. And it does seem like it is this camera here, because that camera is the only one that seem to be reacting to it, so that's good. So the issue is we put the player in a security camera layer. So the player, we're going to put them in the layer player. Okay, so I've got the layers fixed up and I've got the light selected. So what we're looking for is when I move into here, and we can see the color of the light does start changing. It does reset very rapidly as soon as I'm out of the area of focus. So it is a little bit rapid. So that's something where we'd mess with things like our decay time. The decay time probably should go a lot less. So we'll decrease that quite a bit. The other thing that we can now start doing is we can actually start changing the behavior of the camera. So, okay, we know potentially if we've got how detected a target we've got. So what we could be doing is if currently detected target is not equal to null, and we might have a threshold for it actually looking at the player sort of, or the character that's detected. Suspicion threshold. So we might say that that's 0.5. And that's actually going to be a range 0 to 1. So if it's greater than or equal to that, we want the camera to actually change its behavior. So all targets, currently detected target, dot, detection level is greater than or equal to that sort of suspicion threshold. So if that's the case, then we won't try and actually do anything. So otherwise, so if we have a target above the threshold, then don't auto rotate. So we want it to be looking at the player or the thing that's been detected. So there's a couple of things we're going to need to wrangle with for this because it's not the most trivial thing to actually be doing. So, but that's okay because what we can do is we can work this out. So we're going to need to be working with quaternions for one thing. Our desired rotation, going to go pivot point, transform, rotation. So we're going to be having to deal with the fact we're working in a mix of world and local coordinates. We're also going to need to be dealing with the fact that we can see the pivot point is actually, its forwards is rotated. So that does change a little bit of stuff we need to be doing, but that's okay. So firstly, we only want to check if and override stuff in terms of forcing it to look at something if we're within the field of view. So if we're in the field of view, then we need to work out our desired rotation. To do that, we need to get a vector to the target. Vector to target. So, okay, currently detected target, we grab its position. But if we just use that, we'd always be looking at the character's feet. So I'm going to actually set up, so we have a target v offset. This way we aren't always looking at the target's feet. So plus target v offset times by our vector 3 up. Then from our vector to target, we want to subtract pivot point, transform, position, because that's where we'll be rotating around. And we're just going to normalize that. So with that, we can then calculate our look rotation. So we can do a quaternion look rotation, and we can give it our vector 2 target and our world up. Desired rotation can be set to that. But if we remember, the object had some rotation there on it. So what we're going, because a look rotation is in world coordinates, but we're working with something that's already got a little bit of an offset there. So I can bake that offset in here. So that's calculating the location, it's applying that offset, that's good. Now we need to then work out, turn this ideally so that we've got some common code paths. So here we want to calculate the rotation. So this would be a desired rotation. Well, if I just do a quaternion.Euler with these values, that's a local rotation. I need it to be world space. So what I can do is pivot point transform rotation multiplied by this. Multiplication is how you merge and combine quaternions. So we're calculating the rotation. So then what I would be able to do here is pivot point transform rotation is a quaternion rotate towards from the current value to the desired one at, we'll have a max rotation speed by time dot delta time, and I'll set up a max rotation speed here as well. And that, I intentionally want that a little bit above the sweep speed, so that's good. So, okay, that's what we're looking at. So we should probably change when we're doing the raycast, so the raycast is actually casting to that offset point as well. So if we come down here to our target info, well, we can update this so that we have in here plus vector or target v offset times by vector 3 dot up. And we're already normalizing that. Now, one thing do notice here is that raycast. Now, using the forward is actually a really common thing. There's a lot of cases where the raycast, you do use the forward, like for interaction, stuff like of that. But in this case, we're checking if we can see it. So we actually, rather than forward, we should be using vector 2 target normalized. Because we're normalizing it in a few places, I would just normalize it up here so that we're only doing that calculation once. So that looks pretty good. We'll move these up the top. And these can be just set up here. Okay, so we've got those set up. That looks good. Let's test this out. Now, it's possible we could encounter some weirdness. We're doing a lot of stuff with rotations. There is every possibility of strange behavior. But the default looking around, we can see that is definitely going a little bit odd. So we could see the rotation was going a little bit weird. That was because this actually should be using the parents rotation being applied to it. So we do parents and then the local rotation so that they're properly being stacked. So we want to check and see that this rotates the way we'd expect, which that does. That's looking how we would want it to be rotating. That looks good. All of those seem to be behaving correctly. So let's move in and have it detect me. So we can see it's looking at me. And as I move, it continues to follow me, which is good. I get closer, move away. So wherever I move, it's watching me. I move out of view. It then just returns back to its previous behavior. So it's good. We've got it looking at the player now. So the final thing we need to do is set this up so it can be notifying things. So Unity engine.events. Then what I will set up down here, and I'll move that one down here. So what I will set up is a serialized field Unity event that has a game object on detected. And then as soon as something reaches that one level. So what I want to look at here is where I was updating this. So I'm going to set up old detection level, target info detection level, and F old detection level is less than 1. Or I could, yeah, I think depends upon whether we want it to activate on first trigger or not. Probably first trigger, actually. So I'm going to modify this class. Public pool undetected event sent. So we don't want to spam the event. That's the main concern that I've got there. So I'd be checking here then if target info detection level is greater than or equal to 1 and the event has not been sent. Then first thing I'm going to do is mark it as set and then send the event. Target was seen. So that looks good. The other thing might be a useful event is if nothing is no longer is sort of detected. So serialize field, Unity event. And then what we'll have is it won't have anything that it passes through on all clear. New Unity event. And then we can, if we go from having a target to having nothing, then that's where we would go for actually sending this. So I'll have a bool has detected target is false. So down here, we'll make sure that is set to true. And then here, well, we already have a hook for if we've got no currently detected target. So if we have no currently detected target and we have previously had one, that can be set to false. On or clear, we invoke that as well. That's just going to make it really easy for us to keep track of this stuff. And that can also have a public get private set. Actually, we don't need to do that. We can just do public. So we'll bring this up to the top. Useful thing to be able to see. And then what I can do in the security console is just so we know that it's working. Public void undetected target debug log detected, and we'll just output the name. But this you could then trigger off alarms, things like if that on all clear. You could also send advice to AIs that could cause them to go and attack, things like of that. And, once it's detected something, that could pass the location over. So really, really handy in that regard. So let's link these up, and we'll connect them up to our security console in both cases. So the on detected goes to the dynamic function, and the on all clear goes to the on all clear. So what we're expecting is once we're detected, the security console will see a message appear, which we did. It's detected the player. I leave, then after a time, it's saying that it's all clear. So that's where we could be kicking off alarms, all different things like if that we could be running for this. So now our security cameras have got a bit more functionality there. Now in this case we're using it for detecting the player, but we designed this so that it can handle having multiple targets, and it's going to pick the most detected one to be the one that's following. So we've got that as something where if you did use this with multiple players, multiple targets, it's going to be able to somewhat handle that and be able to correctly be looking at the right one. And we can test and make sure that in the other orientations the cameras work okay as well, because we do want to make sure that regardless of camera orientation that it works. And we can see it does correctly follow us. So we're able to see that behavior, and it detects us pretty quickly. So we've got our solid base there for continuing to add and expand to that if we wanted to. Thanks folks, I hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, really appreciate it. If you've got any comments, chuck them in below. If you're looking for the code for the project, that is available up on GitHub, and there is a link to that in the description below that you can follow. You can use that code in any of your own projects, whether those are commercial, non-commercial ones, you're free to be using it there. And if you are looking for other ways to support the channel, I do have a Patreon, and there is a link to that in the description below as well. But until next time, bye.